Hello, 8th grade. These are our notes from August 17th, 2023. So if you were not in class today, this is the information that we covered. We moved on from talking about how we identify or come up with our hypothesis and experiment using that if, then, because statement. And we began working on the next parts, starting with variables in the experiment. So the nice thing about this part is that we've kind of already started to lay the groundwork for that in our hypothesis. And the fact that when we say if and we talk about what we're going to control, we're actually stating our independent variable. It's also known as the manipulated variable, but that is the part of the experiment that we get to control and change and manipulate. And then we use the dependent variable, the responding variable, as our data collection. That is the part of it that we can't control. That would be the part of our hypothesis where we say then. So if I do this in my experiment, independent variable, then I expect this to happen. That would be my dependent variable. And within the dependent variable, this is all information that we can not only measure, but we can observe directly during the experiment. And all that information will get collected and put in a data table to then be analyzed and put into a graph later on after the experiment has concluded. So once we've identified those and we're coming up with our experiment, the next step is to identify those constants. So these are the variables that we absolutely need to stay the same no matter what. So I gave you an example here. If you're testing which type of soil grows the best plants, we would keep things like how much water they receive, the amount of soil we use, amount of sunlight, types of containers, and even the types of plants, just to name a few. So this is a short list. You could have many different constants that need to be kept the same depending on what you're testing. Once these are established, then we can begin the process of writing our procedure. I only have two big things for you in writing a procedure, okay? So number one, procedure is a step-by-step process. Because of that, when you write out your procedure, you're going to do the same thing. You're going to show it step by step. So you can either list it as number one, do this, number two, do this, and so on, or you can use bullet points. This is also the part of the experiment where you come up with your materials list as well. And that's usually your first step. Step one, gather materials. And then they'll see off to the side, oh, these are the materials that I'm going to need. Second part that's important here is that you are very specific in amounts and types of things that you use. You can't just say, step two, get a beaker. What kind of beaker? 1,000 milliliter, 250 milliliter. So you have to be specific on not only the types of materials you're using, but also the overall amounts. The goal is that if you were to give your experiment to somebody else, they would be able to look at your procedure and be able to recreate that experiment using your procedure and hopefully get somewhat similar results. They would be able to duplicate it, basically. Finally, the last part is where you are, or one of the last parts is where you're collecting data. During the experiment, you're going to use a data table. In that table, it's going to allow you to keep track of everything that's happening with that dependent variable as it's changing. So in this case, you would probably have multiple trials during the experiment. So your data table is going to show your times, your amounts, or whatever it may be that you're collecting in each one of those trials. Best rule of thumb is a minimum of 3 trials so that later on you can use that data to calculate mean, median, and mode and range, which we'll get to later on. Once the data has been collected, take the data, turn it into a graph. Typically, in our room, we're going to use both bar and line graphs. Again, we'll go over all the little details of that at a later date. And then finally, your conclusion. So once you've collected the data, done the graph, now it's time to decide, was my hypothesis right or wrong? Typically, your conclusion will be a paragraph, and it's got 3 main points. Point number 1. Got to restate the question and hypothesis. Tell us what you were testing and tell us what you thought was going to happen. Then in number 2, you're going to tell me why or why not do you think your hypothesis was correct or incorrect, and then provide data to support that either way, even if it's wrong. Tell us why by using the data. And then number 3, how reliable is that data? Were there any sources of error? Maybe you mismeasured on your second trial. Maybe you forgot to add something at a certain time in one of those trials. What went wrong, and how can you prevent that in the future from happening again? Say if someone else did your experiment. So at this point, if you were absent today in class, this was where we kind of broke off as a big group, and we did some practice together with independent, dependent variables and constants. And then we broke that down into pairs, and then from pairs to alone. All of this preparing us for you designing your own experiment next week in class. Thanks for watching.